Well, welcome everybody to the May 2018 Mississippi Powershell User Group virtual meeting. Tonight we have Microsoft MVP Thomas Rayner, and he's going to be presenting writing your first Azure function. So take it away, Thomas.
Hey guys, thanks very much for having me. This is a pretty cool opportunity to be able to present to you guys from Edmonton, Canada. It would have otherwise been a pretty long flight. But as mentioned, we're doing your first Azure function today. You can get the slides and the demo code for this and my other presentations on my GitHub, which is linked down below. Check out my blog as well. LinkedIn is there, and Twitter is the best place to contact me if you want to talk about any of this stuff after the session goes. It'll be got a couple monitors, so I should be able to watch the chat. So if you have questions, just put them in the chat, and we'll try to find a organic time to kind of talk about them and stop and do that. Not a lot of slides, mostly demo, so let us just get into it. Oh, I'm just getting over a tiny bit of a cold here, so hopefully I won't be coughing too much, but if I suddenly go on mute for 3 or 4 seconds, that's probably what's happened. So we will get going with Azure Functions. First up, there we go. What's an Azure Function? That may or may not be a piece of technology that you guys are familiar with. So first up, Azure Functions are completely serverless, which means that you don't have to worry about the actual hardware that the code that you're writing is running on. You don't have to worry about patching, OS stuff. A hard drive died. That's not your problem. Depending on your familiarity with Azure and other types of cloud providers, that might be a foreign concept to you, or that might be one that you're super comfortable with because you use lots of other serverless products. The only thing that you have to worry about when you're working with Azure Functions is, where'd I go? Here you go, the code. You're responsible for writing all the code. Whether it's in PowerShell or C# or Python or Java, you can write an Azure function in tons of different languages, including obviously PowerShell. That's why we're here talking about it today. But it's your sole responsibility. You've got to hook up a couple of other items that we'll look at, but far and away, you don't have to worry about any of the infrastructure, just the code. And predictably, I think you probably guessed it by the name, it runs in Azure. So it begs the question, why? Why would we want this? Why is this interesting to us? I can run PowerShell code on my workstation. I can run PowerShell code on servers that I manage. I can run PowerShell code in Azure Automation. I can run it a whole bunch of different places. So what's special about an Azure function that would make you want to run PowerShell code in one of those? And the first is webhooks. That's what this logo is for. You are basically able to create yourself a nice little API that is reachable from anywhere. You can have it plugged into a whole ton of different Azure services and make your modular little piece of code that you store in the Azure function executable and callable and something you can leverage from a whole bunch of different systems. We'll take a little bit of a look at that later. And they're flexible, like this cat. You can do a whole bunch of stuff with Azure Functions that you wouldn't normally think about doing in PowerShell. And it's one of the reasons you can write them in so many other languages as well. But you can, like I kind of mentioned before with the webhooks, write yourself an API. You can write yourself an instant response system and automatically remediate errors. You can do a whole bunch of stuff with Azure Functions that you may or may not normally think about doing. So this is my 4th out of 5 slides, and it's just introducing the demo. Let's just get into it. Let's actually just play with some of these things and show you how it's done, shall we? That one. So I'm just in the Azure portal, and I've just opened the All Services thing here. And we're going to actually accomplish the title of this session, writing your first Azure function pretty quickly. So I'm just going to click on Create a Resource. And if you're familiar at all with Azure, you're familiar with this. Obviously, I can create these through the PowerShell Azure RM module as well, but just kind of for ease of getting our heads around it and kind of exploring, usually that goes a little more conveniently in the portal. So I'll type in function app, Everybody's always better at typing while there's a bunch of people watching and it's being recorded, including myself. And then this is going to look like creating just about every other Azure resource that you're working with in the portal. So I'm just going to click Create. I need to give it a name, which will be its URL. It's .azurewebsites.net URL. So I'm just going to go MSPSUG demo, spelled correctly, and I get the green check mark because that's available. If I put something in that was taken, I would get app name test is not available because somebody already made test.azurewebsites.net. So I'm going to realize that I mistyped the name of the user group as well. Correct that, and there you go. So just like everything else, you're going to have to select a subscription, your Azure subscription that you want to charge money towards. Create a resource group or use an existing one. I'm good with just creating a new resource group with the same name. And then this is cool. You can run your Azure function on different operating systems. So the two that are supported most widely, obviously, are Windows. You can run them on a Windows environment. You can run them in Docker. And Linux is in preview right now. I'd expect that goes live sometime this year, if I had to guess. But it's serverless, so you don't have to worry about the server, but you can still kind of pick which sort of environment you want to run these things in. So if you're running Bash or you're running Python or something like that, maybe you'd prefer if your Azure function ran on Linux. If we're running PowerShell, maybe we prefer it runs on Windows. Either way you can pick. The hosting plan, we can put our mouse over the little information tooltip, and we are quickly advised that the consumption plan, we have choices between consumption and app service. So the consumption plan lets us pay per execution. App service plans let you have a predefined allocation. There's pros and cons to both billing services. Usually when you're a little bit smaller and your Azure function isn't being called as much, you're looking at a consumption plan. And when you're being called pretty reliably and this thing's triggering and running all the time, maybe it makes sense to go to an app service plan that has not a flat billing fee, but it's a little bit easier to predict. I'm just going to stick with consumption plan. Location, this is which Azure data center you want to store your stuff in. I'm going to go West US because I believe it's geographically most close to me. Storage, you can use an existing storage account if you want, or you can make a new one. I'm just going to make a new one, and I don't care what its name is. And you can turn on application insights as well. This is handy for debugging and diagnosing different types of errors and issues that you might have. Where do those app insights live? I'm just going to leave it there. And then you click Create. This automation option is going to take me to the ARM template, basically. It's not a perfect ARM template. It's just sort of taking its best guess at what I've filled out in that list. So you can take this and deploy it as you would love to do over and over again automatically. I'm not going to do that. I'm just going to hit Create. And then these take a little bit of time to actually go. If I click on Deployment in Progress, it'll take me to the screen where I can keep refreshing, and oh, there goes my storage account. If I refresh again, my insights components are there. If I refresh again, it'll take some time. Oh, there's more insights components. And if this takes much longer, I'm going to do the old cooking show trick where I pull out one that I created before we started filming here. 30 seconds. Yeah, this is too long. I don't want to keep you guys waiting. So, oops, wrong window. There. Demo function, Thomas Renner, just like I named it while you were watching. So this is literally an empty function app. This is what you get when that deployment finishes. And you have a whole bunch of different stuff you can look at here. You can delete the thing if you want. Overview, platform features. This is information about the actual function and the apps that you're configuring here. But we don't want to dive too deep into it. We see the URL. This is where our function is going to live. We see the consumption plan. which subscription it's in, and the fact that it's running. We see tons and tons of stuff, but what we do not see is any code. Like, we don't have anything actually written here yet. Like, oh, good, we have a URL, but we didn't actually put anything in it, right? That's kind of important. So under functions, I can hit this plus arrow, and you see the tooltip prompts me to create a new one. If I pop on that, this will load very, very quickly. And we can go through this wizard to quickly start from a pre-made function. We see a webhook or an API. We can have stuff that goes on a timer. We can have stuff that goes through data processing. And we can choose a language. We can do C#, JavaScript, F#, Java. And then suspiciously, we don't see PowerShell. We don't see Python. We're prompted down below for PowerShell, Python, and Batch. You can create your own custom function. And the reason that's happening this way is because these four at the top are kind of the first-class citizens of Azure Functions, the C#, JavaScript, F#, and Java. These are the languages that you're most likely to write a function in, but obviously not the only ones that you can do it. So we're talking about PowerShell. I'm going to create my own custom function. And I'm going to see all the different types of triggers that can make one of these functions run. So I see right away I've got an HTTP trigger. This is going to run whenever it receives an HTTP request. I've got this timer trigger. It'll run on a specified schedule. That's pretty easy to get your head around. So this is just something you call over the web. This is something that runs on a schedule. And as we scroll down, we see things like queue triggers and service bus queue triggers and service bus topic triggers and blob triggers. And these are a little bit more abstract if you're used to a more traditional PowerShell environment. You can read these descriptions and sort of get a bit of an idea of what they're for. But at the end of the day, if you don't know what these service bus queues do, if you're not familiar with storage blobs, then it can be a little bit more of a steep learning curve. But if you've used these queues, basically a function will run whenever a message is added to a specific Azure storage queue. This is handy if you have items that are created and in bursts, so you get a whole bunch of things added to a storage queue at once. You want to run this function on each of them. Things like, you want to take actions of things coming out of Event Hub or IoT Hub or just a generic webhook. You can have stuff that runs whenever it gets a GitHub webhook for an issue or a pull request. There's lots of these. This thing scrolls on and on and on. There's, where was it? Image resizer. That's pretty handy if that's what you're looking for. And one of the things you see underneath all of these triggers is the supported languages. You get C#, F#, JavaScript. And then you kind of start coming down and you see Cosmos DB only does C# and JavaScript. It doesn't do F#. And then you might be going, all right, that's cool. But why don't any of these say PowerShell? Do we just have to scroll further down? No, that's the bottom. No PowerShell. I thought PowerShell was supported. What we've got to do is come up to the right here and turn on experimental language support. And then you see a whole bunch more languages are going to appear underneath each of these different descriptions. And some of them have a whole bunch, like Bash and Batch, PHP, TypeScript, Python, PowerShell, all got added to queue trigger, whereas just TypeScript got added to service bus queue trigger. So you do have to make sure that whatever trigger you want to write in has the language associated with it that you actually want to write your code in. We're looking for PowerShell, and I'm just going to keep things relatively simple with an HTTP trigger. So I'm just going to select that by clicking it, and it's going to prompt me to create a new function. By language, I get to pick from all of the different languages that are eligible to be used on this trigger. Go on PowerShell. And I can give my trigger a name. I'm just going to leave it like this because I'm very creative with my naming. And this isn't going to go into a production environment or anything, so it doesn't really matter. Authorization level, if we click this little I for information, we are informed that this controls whether or not you need an API key and which key it uses, because you might want to have a function that's exposed where the entire world can go and hit it, or you might want to have a function that is very limited and you need a specific API key in order to use. I am going to go anonymous because I don't want to limit anybody from using this wonderful, imaginative, very useful Azure function that we're going to be writing. And then we get a little warning here because we're not using one of the first class languages. We're using PowerShell. This language is experimental and does not yet have full support. If you run into issues, you can file a bug on the GitHub repository. And I don't know if you can see in the bottom left corner that shows you where it goes. Maybe I can just open this in a new tab. If we run into problems, rest assured we're going to go create an issue on the Azure Functions Templates repository. But we're good with that. I've selected my language. I'm just going to hit create. And this is going to give us a home for our code. There we go. So you guys saw I didn't type anything. It came pre-populated with a whole bunch of code in it already. It came with stuff for post. If you post to this HTTP endpoint, if you try to do a get from it, and then an out file. And all this code is great. It's default. We'll cover what it does in a second. But what I want to show you first is if I open up this pane, I get a couple of different items that we can look at. I've got the files that make up this function, and we're looking at run.ps1, which is just the default PowerShell file that gets run when you hit the endpoint that we just created. But we've also got function.json. So if we click on that, this is where we kind of configure the bindings that this endpoint is going to use. We've got an HTTP trigger, so you're going to call it over the web, which means it's got different types of bindings than if we were creating something that took input over an event grid or something like that. And so Azure Functions is doing us a pretty big favor, to be honest, by pre-populating all of this. You don't have to come up with this from scratch. This isn't something that I pre-configured. This is just what happens when you create an HTTP trigger for a PowerShell Azure function. So we've got two bindings. The first binding is REQ, or request. It's for an HTTP trigger, and the direction is in. So we're kind of going to be able to dissect this and go, the stuff that comes into our Azure function is going to get stored in this REQ variable, is basically what this means. It means that the authorization level is anonymous. You guys saw me configure that a second ago. But that's great. Okay, so we can have input, but we need to be able to send output as well, right? So that's what this second binding is. This is a binding to an output stream. The type is HTTP. The name is res, which is going to be short for response, and the direction is out. So we've got stuff that comes in under our REQ variable, and we've got stuff that comes out under the RES variable. I know this part's going kind of fast, but the reason for that is because I don't usually goof with this a whole bunch. I'm sure you could create a whole bunch of different cool things in here, but when you're dealing with PowerShell, this pretty much just stays as it is. You can disable it here if you wanted. Disabled is false, so it means it's enabled is true. And then that's really all we need to worry about in this function.json, especially when we're just kind of doing our very first one. So if we go back and look at run.ps1, I'm going to collapse this again, so where can I resize it? Nope, okay, I'm just going to collapse it. We've got a couple of different options here. So now that we know what rec is, that's our input. That's what's being sent to us. If we want to post to this, if we want to send it a message with post as the method, then we're going to do a get content on whatever was in that request, treat it as raw, and convert from JSON. So what this is indicating to me is that this function is expecting us to pass it JSON as input when we're posting to it. And then we've got this name equals request_body.name. So this request body is just the body of the request converted from JSON into a PowerShell object. And then this .name is here. Let's skip over the get method just for a second. And then what we have is an out file, dash encoding is ASCII, file path is this res, and then the input object is hello name. So what the hell is happening here? Why are we writing out file? That's kind of weird, isn't it? Encoding, that's neither here nor there. Okay, it's going to be ASCII. The file path is what's important here. The file path is our response. In the function.json, we saw that res was going to be our binding to our HTTP out stream. And what's happening here is this is basically a pipe. So this file path that's stored in our response variable that's generated just by virtue of having this function, whatever we write to this res file or output stream is going to be what gets returned to our person who called our web app. Then the input object, okay, what are we going to actually say back to them? We're saying hello name. Everybody on board so far? The chat's quiet, so I'm going to assume we're good. Again, bit of an abstract concept because we're dealing with these HTTP triggers. If you were dealing with a different kind of trigger, you'd have a slightly different example that starts with a different boilerplate than this. The get, real quick, the difference is here, if we're passing information through a post request, it's coming into the body of the request that we're creating. If we're doing it through a get, then this information is going to be passed through a variable in the URL. That's how those gets work. Down here at the bottom, we have logs, and we have you're not connected, no new traces. We have errors and warnings that we can look at. We're going to come back to these logs in a second, but what we can also look at is this test. We can test these things right from the browser. I haven't even opened PowerShell yet. In fact, I probably should have opened it before we recorded because my profile can be finicky sometimes. But this test, I've got HTTP method. I can do either a get or a post, or I can try any of these other ones if they made sense for the trigger I was using. But I've got post. There's no query parameters. There's no headers. And it's giving me just a default body that I can test. And this looks like JSON. It's going to be the name, and we're going to set it equal to Azure. Again, I haven't configured any of this. We're just kind of taking a look at it. So what do we expect will happen if I hit run? Any guesses? Any ideas? Let's try it and find out. Hit run. It's going to try to do a little bit of work here. And so a couple things have happened. The first is I'm going to expand this log so you can see it a little easier. I'm going to collapse that for a second. We had no new trace, and then function started, and it had an ID, and then function completed. And that looks pretty mundane. Okay, good for that. If we look back on our test, we got output. We got the status was 200. Okay, that was the HTTP code that got returned. We didn't get a 404 or a 403. We didn't get any type of error with our input. And we actually got just regular output. We got hello Azure with a new line at the end. Okay, so let's jump back a little bit here and dissect how we got that. So we look. I wish I could collapse any of that just to make it a little easier to see. If we look again here, the request body is that JSON that we're passing it. So that's our name equal to Azure. And then we're isolating the name that we're passing, and we're assigning that to the variable name. Then we didn't have anything get. Our method was post, so we're skipping that. And then out file, what we wrote to the output stream was hello name. So as we went name equals Azure, we got hello and then the name that we put in. If I change this to MSPSUG and I hit run again, I get hello MSPSUG. Pretty good so far. So hey, we've got an Azure function and it's up there working. Let me pop open PowerShell and I'll show you how we can hit this from somewhere else. If we went invoke REST method and we went method post and body, how should we do this? Let's go. New keyboard and it's different than what I'm used to. And That's taking forever. There we go. All right, get back here. So what I've done here with the body is I'm just creating a hash table with a name equals PowerShell, and then I'm converting it to JSON. And what I want to create is basically what I've created here, where I've got the request body, and I've just got name, and then it's equal to something else. This colon is just an equals, an assignment operator in JSON. And what I'm doing here is I'm still doing post, and the body is going to be name equals PowerShell converted to JSON rather than sending it a PowerShell object. And I'm using invoke REST method because I just want to treat this like an API. I don't actually care about all the different HTTP codes and stuff that comes back with it. So I'm missing a piece here, aren't I? I've got method, I've got body. That's what I had to fill out here. I got method, I've got body, but this thing exists on the interwebs. This thing exists outside of this little test environment. This thing is not running locally on my computer. I need to provide a value for the URI parameter, don't I? And how do I find that? By clicking the very handy get function URL. I can change which key I want to use, but I'm using anonymous access, so it doesn't really matter. And I'm given this URL. You'll notice it's HTTPS, so it's SSL protected, which is really handy. And then I've got the name of the function app that I've created, which was the demo function Thomas Rainer, then /API, and then I've got the name of the trigger that I created. And so if I had more than one trigger, like maybe this function can get called by my HTTP trigger, maybe it can be called on a timer, and that timer has a different name. Maybe it can be called, I don't know, through a webhook, and that has a different name. That's how I can tell apart which endpoint I'm actually going after here. So I'll hit copy, I'm going to close that, and pop open PowerShell again, and paste that right there. So unless I've made an egregious typo or error in logic without formulating this body, if I just hit enter, I get back hello PowerShell. Because what's happened here is actually pretty cool. If you think about it, I've invoked a REST method, so I'm reaching out to an API that exists on the internet, and I'm posting to it. I'm sending it data in the body of my message that I'm sending. That data is JSON, and it's just the name equals PowerShell. And there's my URL. And it's returning me information that it dynamically created and figured out all on its own. Pretty neat, right? That's our very first Azure function. It's obviously not all we can do with Azure functions. It's not all we're going to do right now. But that, in a nutshell, is how you get started with this stuff. So you obviously don't have to do your programming in this web interface, but we're going to keep doing it here anyway, just because it's kind of better for simplicity. You can overwrite these bodies through CI/CD pipelines. You can do it through AppVer. You can do it through VSTS steps. You can do it just through raw PowerShell and build the thing yourself. But I'm just going to keep doing it here because I've already got it open, and I don't want to build a full pipeline just for this demo. So if I go, I'm just going to backspace out this this get real quick. Because we're not going to use it, we're just going to keep posting. You can see it's not very difficult to use the get queries as well. I just prefer the post for these REST APIs. And I'm going to show you guys what it takes to use different variables and how we can set that stuff up and configure it. So I'm going to take out this name. And you know what I want to do? I'm going to make... let's make it roll a roll of dice. We'll get a random number generated, and what we'll do is the user is going to provide the minimum value and the maximum value, and we'll get them a number between the two values that they provided. So I'm going to need something for min, and I'm just going to steal the syntax from this because it's so convenient. We'll go min equals request body dot min, then we'll go request body dot max, and we'll get rid of this name, so don't need it anymore. And so how do I know it's going to be min and max? Well, because that's what I'm going to pass it when I'm calling this thing. This is why it's important to document your APIs and make this stuff so that you can actually have other people use it and have it discoverable for others, because this isn't something you can just run get help on and get information returned. You've got to actually document this and share it with people. What is your API expecting as input? And then we should probably have a little bit of logic. We'll go if min is less than max. This is our good case, so we will I've been really forward thinking out of copy. And then what we want to do, we want to return that number to the end user. So I'll take that line of code and put it right there. And so our logic here, if our minimum is less than our maximum, that's good. We'll get a random number between the two and write it out to the file. If this is not the case, so if our user has made a horrible error, this is super basic rudimentary error handling. Obviously, you'd want to do more than this, but if our maximum is less than our minimum, then you got them backwards or you screwed up. And what we're going to do is tell the user, you could have this return an actual HTTP error, and you can set it so that it's not doing, not going to reply with an HTTP 200. You can have it reply with like a, I can't remember what the code for malformed input is, but you could have it reply with a specific HTTP code and then give it a specific method. What I'm going to do here is your max was smaller than your min. And if I really want, I can go put in the square bracket. I'll go min and max. And that'll allow us to go, oh, what did it receive for a min and what did it receive for a max? Because maybe this is coming from somewhere other than just us typing it at the command line. So that's looking pretty good to me. We've got a request body. It's still being received and converted from JSON. We've got a minimum that's coming in from a variable named min that we're going to pass. We've got a maximum coming from max. If min is less than max, that means that we've passed it correctly, and nobody's corrected me saying you got this logic backwards, which I've been known to do. So I'm going to assume that's right. We'll get a random number and send it back, and otherwise we'll say, hey, you messed up. Good, right? All that's left to do is hit save, and I'm not going to hit save and run, and you'll see why. If I hit run right now, get kind of some unexpected output. It was okay. I got it in 200 back, but I got your max was smaller than your min. Then min, nothing. Max, nothing. What happened? Well, let's see. There's that cold I was talking about. All right, so my min and max were both blank. Things didn't really come out like I expected, and that's because the body that I passed it still just has name and MSPSUG in it. So that's not what I'm looking for. I'm looking for a min and I'm looking for a max. I'm not looking for a name. So I don't get an explicit error just because these things don't exist. Think about PowerShell. If you try to do a property that doesn't exist on a variable, it just gives you back null, right? Like if I go items, oh, back here. We'll get child item. That's great. And my items, that they have properties on them like count and isFix size and stuff like that. And if I actually, and I'll get information back. Like if I go count, I've got 13 items in this directory. So I go items dot does not exist, null. So we're getting exactly the behavior we expect, or that we should get. We passed it a property called name, and we didn't use it anywhere. We're looking for a property called min and a property called max, but we didn't actually pass that information. So these are equal to null, which is why we're not getting anything back. What we can do instead is actually pass that information and go min is going to be, let's make it 1. I say 1. And max, let's say, is 10. Is it 10? So we're going to get a number back between 1 and 10, we hope. And if we run that, 6. If we run it again, they get 6 twice in a row. That's 2. There we go. We get random numbers back and forth like we think we should, because it's finding this min and it's finding this max, and it's able to assign them to our variables and enter into this branch, so that it's saying if min is less than max, do the stuff. So if we make this 1,000, now min is no longer less than max. We should get our error. Your max was smaller than your min. Min was 1,000, max was 10. Looks like stuff's working. So if we go in back to our PowerShell session, I'm just going to kind of edit part of this. I can begin doing kind of the same thing. Backspace, there we go. Min equals 1 and max. If I see a question, I'll be right there. Max equals, and that should be good. And enter. Get back 1, and enter again. I get back 7, 2, 2, 5, and this comes back really quickly too, because this function is already warmed up. It's already running. If this was Azure Automation, you'd have to wait for an Azure Automation instance to get provisioned every single time you wanted to call this thing, and it would take a whole lot longer. These go crazy. The question from Marvin is, could you call another Azure function from run PS1? Yes, you could. Either depending on how you have it set to trigger. So if it was another HTTP endpoint, you could just do an invoke REST method like that and pass it information through the body parameters as well. Or if it had a different type of trigger, you could use that instead. You can use the Azure RM module also to kind of fudge with a bit of that and instantiate another instance of that Azure function, but the best way to do it is through a trigger. So yes, you absolutely could call another function. And also, if I had other files that existed in this view files view, I can either add files or I can upload new files, delete files. So if I had a PowerShell module in here, I could import the module here. If I had scripts that I wanted to .source, I could upload the files and .source them and use the functions that were in them in here. So we can, if we wanted to go .source, I can go here and I could go function get thing. I can just go right. And I'll save that. And then if I go back to .ps1, or sorry, run.ps1, I could go up here and go .source this .sourced one, and then I could run this get something function that I created in this .sourced file. So you totally can use that. You can go and install modules from the PowerShell gallery if you want. You can do a whole bunch of different stuff. If I decide I don't want that, I gotta save this change. .sourced, I can delete that because I'm done with it. And I can do a whole bunch of stuff there. If I come back here, just to kind of prove a point, I can min 100 again, and I'll get my error, just like I expected. And if I pass it stuff that it's not expecting, like here's a functional example, 7 again, 3, there we go. If I pass it some more information that I do not care about, I think it's going to be bothered at all. Don't equals. Pass that through. Doesn't matter. I don't have to get the body very exact. As long as I give it what it's looking for, then that's fine. If there was a certain parameter set that required me to pass some input but not others, then you might run into some problems. But if I pass it extra input that it doesn't have anything to do with, you can see I don't have, I'm not referencing the don't care variable on any of this stuff. It's just going to be ignored. It's part of the request body object that gets passed in, but it doesn't actually do anything in my script other than take up a little bit of memory. So that is building your very first Azure function. And this is sort of how you can work with the inputs and outputs to make this stuff work like you want it to. Obviously, this is just a little random number generator that we built as I was talking to you about it. But this is where you're going to be receiving body in through a post request. This is how you're going to be writing stuff out. And that is basically your return statement in a lot of ways. If we look at, and so that's coding your Azure function. If we look at this integrate section down here, I can have different triggers. I can have new inputs. I can allow different HTTP methods. Maybe I don't want to allow gets or patches and things like that. I can change the request parameter name. I can change the authorization level to go lock this thing back down. I can change it so that it's a webhook instead. Route template. They haven't honestly not goofed with this one that much, but it's to do with kind of differentiating, differentiating who's calling your stuff. You can add documentation. We had a really good conversation about that in the chat before the recording started. You can add a whole bunch, or this is information about how to use it and how use the C# code from a GitHub webhook function. This isn't a ton of PowerShell code in here for you. But here's a whole bunch of settings on how you integrate with other items. You can open this advanced editor for more. Under Manage, this is more useful for a lot of people. This is where you manage your API keys. And so you can do this through PowerShell as well, or you can do it here. But we have ours on anonymous access, so it's not really important. But if we had a few different systems and we wanted to delegate API keys to it, then this is where we could add a new function key or a new host key. And we could say this one is for Mike, and we could let it auto-generate a key and say save, and then save. There we go. And then we can get Mike's key right here and copy it and then distribute that to Mike so that when Mike is using our Azure function, he uses his own API key, and then when Thomas is going to use it, he uses his own key. So there we go. So we can have separate keys, and that way when Mike gets promoted into management and he doesn't do any work with this anymore, I don't have to impact Thomas's work. I can just hit revoke on Mike's key because he's not doing it, and now I don't impact any of my other users. This could be other systems like your build system or a release system or something, and you can add a function key or a host key depending on your needs. Monitoring, this is pretty handy as well. If we let this load for a second, we're going to get a whole bunch of cool information about how successful our operations are. So we can see exactly when in UTC this thing is being called. The success was true, result code 200. I can get more information or run it in App Insights. Again, this is really helpful when you're debugging stuff. So here's all of the different runs that we've done of this particular thing. And if we go, oops, not that, this. If we go generate an error on purpose, it's not converted to JSON. Let's see what happens. I'm going to pass a PowerShell object. And, oh no, explosion. We got the red text. That means we don't know how to do our jobs. Invoke REST method, ID, request ID, error code, message and errors occurred. Very descriptive error. And if we go back and look at our monitor log and hit refresh, we should see, oh, results may be delayed for up to 5 minutes. That's handy. What we're going to see is that error come in eventually. If we try really hard and believe in ourselves, it may even come before 5 minutes. You'll have to just take my word for it. That error would appear in this log, and we could look at the different types of stuff that was going on with that, and get a similar piece of information as this, except it would have our error messages as well that we could also run in Appian sites. Come on. Nope. Okay. This proxies is not something that you'll normally goof with the whole time, depending on your scalability. Slots is a preview feature, but what this allows you to do is have like a staging and a production next to each other, and you can deploy to staging and test it out and divert a certain amount of your traffic to staging without interrupting all the traffic that goes to prod. And then when you're ready to promote staging to prod, you can just switch it over, and it will change how the virtual IPs work, and it'll just kind of cut you over really quickly. It results in very little downtime, and that can be really handy. And so, let me just confirm here, function apps. We've got the different apps I've got. Here's the app I've made. We've covered this screen, looked at the actual trigger itself and the code that we've come up with. I think that is about all I had to show you guys. How are credentials handled? It would depend on, I'm sorry, excuse me, which types of credentials you mean. In Azure Automation, there's this concept of a credential asset, and you can store credentials in what are effectively a vault that is just for that automation account. In Azure Functions, probably what you would do is use an Azure Key Vault and coordinate between your code there and your Azure Key Vault, because you don't want to store the credentials in amongst these different files. There we go. In among these different files, because you don't want to set in plain text, you don't want to have them hard coded. I would put them in an Azure Key Vault and get them out of there. I know if you have like Thycotic, some of the different password managers have APIs that you can hit. There's no explicit vault or anything connected to Azure Functions. So if you have credentials or secrets, you're going to want to pass them in as a parameter to this thing and pass them in as though they were min or max and get them from an external system, whether that's something that you maybe you're passing a secure string or a credential object or even a plain text password, whatever you're actually working with in the body here, or it could come in through a different piece of information depending on your trigger. So there's no one-size-fits-all for handling credentials. Obviously, it's a very important part of what we do, and that's a really good question. And the answer is the ever unsatisfying, it kind of depends on your trigger, on where the credential is going to be used and how it's going to be stored. Azure Automation has the concept of a hybrid worker where you have a server that you set up on premises that you have control over. These just run in the cloud and are serverless. That's a great question. What I have next is just my thank you for you guys coming out. That is about all I have to actually share with you. I wanted to give huge thanks to the user group itself. You guys have fantastic organizers, and I can't say enough good things about them. I've had the pleasure of knowing Mike for a few years in particular. All those guys are the best, and we as a community are super lucky to have guys like that who are committed to continuously putting on awesome events and soliciting speakers. It takes a lot of work, and I really appreciate the work that they do. I also really appreciate all of you guys for sacrificing part of your evening, or in Josh's case, part of your afternoon, to come and listen to me talk. I hope you had something valuable come out of this. Maybe you'll play with an Azure function. Hit me up on Twitter if you do. My contact information is all up there right now, and I'd love to talk more with you guys about anything that you do come up with. Otherwise, thank you again so much. I've been Thomas Rainer, and you guys have been awesome. Thanks very much.